the link into the chat for session editing. All right, so welcome to the continuation of TEAS in London. Thank you all who have come back. We've lost more than half the room. We'll see how many come back in and how many just need to log in using the QR code. We have the usual public service announcement. Please wear a mask. Please wear it properly. Please wear a proper one, except if you're speaking at the front of the room. And we have the IETF Note Well, which is the one administrative slide we're required to show. So we're showing it. Everyone was here in the previous session, right? So you know it. And if you weren't, please just go take a look at the link at the bottom of the page if you're not familiar with rules of contribution. And with that, we're going to move right on to Shusong.
Hi, this is Xuesong, and I will introduce our update about IETF network slice application in 5G end-to-end network slice, presenting other co-authors. Considering this is a hot topic, so it's very glad to present in this IETF. Next slide, please. Just a very brief overview of why we have this document. There are a lot of applications for IETF network slice, and we think 5G is one of the most important application scenario. So we have 3 documents about this topic, and before IETF114, we are suggested by the chairs to merge these 3 documents, and during the process we collect a lot of feedback from the TEAS working group, so we also modify the contents and some missing point, and we have a new document for this topic. And basically, this document is trying to answer the following key questions. The first one is the role of IETF network slice in 5G network slice. And the second one is the existing 3GPP work that has already been done, which is really related to IETF network slice, and how to map 3GPP network slice to IETF network slice. Next slide, please. Here is the draft structure, and we really make some progress in the new version, the version 1, and make the structure more stable. In section 3, because we collect some feedback from community, so we update the figures and terminologies to avoid introducing unnecessary 3GPP concepts to make IETF people confused. And for section 4, we give some overview of the mapping between 3GPP and IETF network slice between going into details about the mapping process. And for section 5, we clarify the relationship between the existing 3GPP parameters that have already been defined in TS 28.541, clarify the relationship between it with the IETF network slice. And in section 6, which is the main part of the document, we modify descriptions and terminology, some updates in terminology. Next slide, please. This slide actually has already been introduced by Reza in next IETF. The motivation here is just to show the scope of this document to answer what is the role of IETF network slice in 5G scenario. The scope of this document, what we are trying to cover is all the connection between 5G network functions that can be connected by an IETF network slice. So depending on the RAN technology deployment, there may be a different interface that can use IETF network slice to connect the different network functions. And based on the comments from community that I have already mentioned, we just replace some of the detailed concepts from 3GPP side, and we just think different interface may introduce no difference for IETF part, so just make them all showed as network functions for in the picture, and to show what the IETF network slice will be inside different scenarios. Next slide, please. Yes, and here we give some, this is a new section. We try to give some overview of the mapping between 3GPP and IETF network slices. We just take the connection between RAN and UPF as an example and show the options realizing 5G end-to-end network slice mapping. For example, the V-line, here we introduce a new terminology, we call it handoff or handoff ID, which is used between 3GPP side and IETF side to just do the mapping in different scenarios. And we give some examples about how to do the mapping. For example, VLine as the handoff ID, MPS label as handoff ID, and SR6 seed as handoff ID. I have to mention that all these three options has also been defined in 3GPP parameters. So we think it works. We also give some considerations for the case of policy-based routing and GTPU, UDP source port-based mapping, which is defined in another document in DMM working group. Next slide, please. Yes, I think this part is one of the main progress in this version, because we think the EP transport, especially the related parameters defined in EP transport, is the most related part in 3GPP to connection with IETF network slice. And we can see the parameters that have already been defined in EP transport in the table. It includes the IP address, logical interface infer, next hop infer, and queues profile. All these attributes could be used in the mapping of 3GPP between 3GPP network slice and IETF network slice, especially the next hop infer, which identifies the ingress transport node. Each node can be identified by any combination of IP address of next hop router of transport network, system name, port name, and IP management address of transport nodes, which means that we can use information of this information to choose the PE node in TN domain. And also another important set of parameters is logical interface infer, which is a set of parameters include logical interface type and the logical interface ID. It specifies the type and the identifier of the logical interface. As I have mentioned in the previous slide, it could be a VLAN ID, MPLS tag, or segment ID. So this is assigned equally per slice, so it can be used to map 3GPP network slice to IETF network slice. Next slide, please. Actually, these figures we have presented several times in IETF meeting. It just shows the overview process of how we do network slice mapping. Basically, the NSM, this terminology is from 3GPP side, but it equals the orchestrator in IETF framework document. The NSMF will receive some request from the customer and create a network slice, and the requirement and will be separated and to push the subnet controller to create their own network slice to make them all together to satisfy the overall requirement. And for the IETF part, the IETF network slice controller will create the IETF network slice and with the IETF network slice identifier. And in this progress, there will be some mapping relationship allocated by the management plan to the CE and the PE node to let them know which 3GPP network slice will be mapped to which IETF network slice handoff ID. And for the PE side, it shows that which IETF network slice handoff ID will be mapped to which IETF network slice. And next slide, please. We think after a lot of discussions among the authors and a lot of work from contributions, and also we collect a lot of comments from the working group, I have to admit that we haven't closed all of the comments and we just list them in the GitHub, but we think the structure of the document is quite stable, and we think it's a good start for further discussion about this topic. So we request for working group adoption, and always reviews and comments are welcome. We will have weekly call meeting, and it is open to anyone who is interested. And we will keep modifying the document. Actually, there is a meetup among the authors this morning, and we will slightly change the order of the document, but the contents are, we think, are stable, and we will give some detailed example about how to do the mapping, especially use the NBI YAM model that has already been adopted by working group. Yes, that's all.
Okay, notwithstanding going over time, so not really leaving time for this question, which is definitely bad form, we're going to ask the working group whether or not are there any objections to adopting this document. Raise your hands if you object. Lower your hands if you've read the document and you think it's ready. And if you haven't read it or don't have an opinion, please don't do anything. And we're going to bring up the next presentation.
Sure.
So it's Julian. So an interesting thing is when you change presentation, it ends the poll. So you had a very, very short poll with not a whole lot of participants, and I have no idea what's going on there. But the conclusion is it's really mixed and not huge support. So I can't judge whether it was because of the time or not, but if you're going to ask the working group to adopt your document and you want us to take it seriously, you got to leave time for that. Thank you.
Right, hi everyone. So this is talking about the realization of IETF network slices for the 5G use case using current IP MPLS technologies. And this is on behalf of all of my co-authors who are listed here. Next slide, please. So by way of reminder, the overall goal of this draft was to take 5G slicing as the use case and to see to what extent IETF network slices can be implemented using current IP and MPLS technologies. Next slide. And so here are the differences between the current version, which is 02 and 00. 01 had a lifetime of about 1 hour because of something that we forgot to add, and so it became 02 1 hour later. First of all, we'd like to welcome Reza, Louay, and Benny as co-authors to the draft 02. In section 2, we added some extra material because what we wanted to do is to describe how the overall data path from a network function, which might be on a compute in one DC, to a network function somewhere across the network, again, perhaps on a compute in another DC, how that end-to-end data path has several different sections to it under the control of different orchestration, because you have a sort of sandwich where you've got what we call a local segment, then we've got the transport segment in the middle, and then a local segment on the other side. The local segment's being controlled by the service management orchestrator, while the transport segment in the middle is controlled by the IETF NSC. And also we mentioned some special cases where a data path between a pair of NFs could just be a local segment because they're co-located in the same data center. Still with section 2, we previously had an overview of 5G networking as pertaining to the content of the draft, as relevant to the content of this draft. But for ease of readability of the main body of the draft, we moved that overview to Appendix B. Now, section 3 in previous versions had discussed 2 handoff methods between, for example, the RAN domain, represented by DC, and the also mobile core domains and the transport network. The 2 previous methods of handoff discussed were VLAN handoff and also IP handoff. IP handoff, by way of example, being if you've got IPsec running between a pair of NFs. And so in this new version of the draft, we added a additional handoff method, namely into provider option B. And this is well suited to a situation where, let's suppose layer 3 VPNs are used as the underpinning. The layer 3 VPN VRFs are actually located on the compute, perhaps on a virtualized router, on the same server as that hosting the network functions. And that its routes are communicated via BGP, perhaps to a DC gateway, and from then to the PE that faces the DC, and so on across the network. So what you have in that situation is into provider option B. So we wanted to document that. And then finally, we have a new section, section 5, which talks about how one could deal with or not 5QI. 5QI stands for 5G QoS indicator, of course. That in itself isn't a direct attribute of a packet, but sometimes people map that 5QI value to a DSCP value. And so one model is you say for a given slice, that slice is mapped onto one particular queue as it travels through the network, and therefore it's 5QI unaware. Or the other model is 5QI aware mode, where according to 5QIs that exist, multiple of them within the same slice, encoded onto DSCP, those different packets could be mapped onto different queues as the packets travel across the transport network. And we have corresponding diagrams by way of example to illustrate each of those two cases. So now let's move on to the final slide, please. So finally, given that we've received a lot of interest in the draft, we'd like to, as a next step, request adoption as a working group draft.
Shusong?
Hi, Julian. This is Xuesong. Thank you for our presentation. I just think this is a really interesting topic, and I think it's a valid matter to realize IETF transport slice in 5G scenario with existing technologies. Still, I have seen some possible overlap between my document and your document, because we both focus on the 5G scenario, and even the something like handoff ID maybe also both considered in our document. So I just want to seek your suggestion or suggestion from chairs or working group. Do we need to cooperate together with these two documents, or we can coordinate better with our different contents?
Yes, they do certainly cover similar ground, and therefore there is some degree of overlap. I mean, certainly we can look to see, how one could address it. I mean, one method might be, if there's places where there's a lot of overlap, we remove the overlap. So instead of having the overlap, one draft cross-refers to the other and says, for more detail, look in section 5.1 of this other draft. Or, the other extreme is, merging the drafts. So we could, look in detail at, the sort of overlaps and non-overlaps and see, what can be done accordingly, I would suggest. Because they did come out at about the same time, so it needs, so, in places they do cover similar ground. Yeah.
Sure, we can talk afterwards. Thank you.
I think the motivations of the two documents are slightly different. There is some text in this document that could clearly move to the other document, but in terms of the motivation of the document, it's clearly different. G?
Hi, Xinong from Huawei. I think this document is interesting. It provides one option to realize to support the 5G network slicing with existing IETF technologies. And actually in this working group, we also have other options for this similar purpose, like VPN Plus. And as you mentioned in the slides, you say that you want to describe to what extent the existing technology can be used in this scenario. And I would suggest to include this in the document so that you can say the applicability of this existing technologies and also the limitations. That would be useful for people to understand the difference between different options so that can choose a suitable tool for their network.
So are you suggesting we analyze things that are not under the category of existing, IP/MPLS technologies by way of contrast? Like, are you saying, even though the main sort of direction of the draft is using current IP/MPLS technologies, are you saying we ought to weigh it up against alternative technology X, Y, and Z in order to highlight, potential advantages of the direction we're advocating? Is that what you had in mind?
Yeah, my suggestion is, as you mentioned in the slides, you want to identify to what extent this mechanism is suitable for the 5G network slicing. So I suggest the document could specify this in the text, with some text. So which are the applicable scenarios to use existing technologies? So that will be helpful for people to understand when they can use existing technology and when they will need some enhancement to achieve maybe for some critical services in the 5G or other scenarios.
Yeah, I mean, certainly the overall sort of premise of the draft was asserting that one could address the 5G slicing use case using IP/MPLS current technologies, and then the body of the draft then exposes that, explains that. So that was the sort of overall purpose, and that's the thrust of the draft.
Okay, maybe we can discuss offline.
Yeah, indeed.
Okay.
Yeah.
Unfortunately, we've pretty much taken the rest of your time. Reza, if you want to ask a question while the next person comes up, that would be fine. It's Drew.
Reza Rokui from Siena. As a co-author of both documents, this document explicitly talk about the realization detail of that, and the document that Susang explained is one layer up and it's kind of abstraction of that. It would be a good idea to next meeting we put a hierarchy of all these documents together, how they are related. The title is the same. For people who don't know it, they might be not clear, but definitely there is differences between them.
Thank you for the comment. Thank you for the presentation. There's clearly interest in the topic, so we'd like to hear more. Certainly, if there's parts you can combine with existing documents or other documents, that's always great. It seems like you're not covering exactly the same topic, so there's room for multiple documents here. Thank you. On to Dhruv.
Yeah, I'll be talking about network slicing mapping. So on the same lines, next slide, please. Basically, we have a working group document, which is TEAS service mapping. It defined a grouping. That grouping has been used to augment L3SM, L2SM, L1CSM with mapping of how this service uses the underlay TE resources, whether it is in form of VNT topology or tunnel. The same thing we also apply for network models. And this work has been going on in the working group for a while now. But one thing was missing, that we don't have a similar thing for IETF network slices. And at the same time, we didn't want to overload this current document, which is anyway very big. And even the mapping requirements are a little different, because especially with NRP coming into the picture. So it makes sense to have a separate document, which is talking about how do we map slice service to the underlay TE resources. Next slide, please. So this is that mapping model. Basically, the new requirement also is that we need to map to NRP. So once we have got the NBI, which is the top level, we are mapping that NBI to what is the NRP that is instantiated in the network. And then if L3NM like services are being used, as Lewis had presented in the earlier presentation with the mapper and the realizer, if the below thing is a network model like L2NM or L3NM, you can have a mapping to that as well as maintain the mapping to NRP. Plus, we can also map to TE resources. So that's the next slide. So the existing mapping that we had for TE resources, that can also be done. So we provide flexibility. In this case would be like in the previous presentation, which was trying to use the existing technology and not create NRPs. Yes, that's fine. You could directly map things to the T resources. This mapping realization model would allow that. The idea here would be that this mapping gets populated when you do the realization of the slice. You could also allow configuration only in cases where maybe if the topology is exposed already to the customer, they can also do some more control over how the network, how the things are realized. That option, I don't see it being used that much, but currently it is there. We are looking for feedback whether that should be there or we should just make this read only and not allow configuration at all. Right now, it is allowed. So we want to get feedback for that as well. And continuing in the same thread, there is a possibility also to have multiple map types. So right now we are basically borrowing things from how we have done for IETF networks for the TEAS service mapping. We wanted to see what needs to apply for IETF network slice as well and what we should change. So looking for feedback on that. Next slide. Very high level, this is what we are augmenting IETF network slice. Define a container called mapping. You can map to NRPs, to L3NM, L2NM, or to TE. In case of TE, we simply reuse the grouping that already exists for TE service mapping, and that's basically what the current model design is. Next slide. This is the tree. I think we can go to the questions and use that time. So first question in our mind right now, I have only done the mapping for slice, that at the IETF network slice level, I'm mapping it to NRP. Do we need to do mapping at the other constructs like at each connection group level or connectivity construct level, or is that not necessary? This is not very clear as of now, so we want to get more feedback on that. Similarly, should we map SDPs into, say, sites of L3SM, LTSM, or let it be figured out during the realization time? There is no such clear requirement that this kind of mapping would be useful or not. That is not clear. So we want to get feedback on that. Should we allow multiple map types, etc.? And of course, the major work would be we need to add some examples to make sure that people understand how to use this model and how would it be useful. So that's also something work to do. And maybe if there is consensus that this is useful, we can go and update Lewis' earlier documents and add this one as also one of the Yang models that could be used when we are thinking of how IETF network slices are realized. I think that's my last slide. So questions, please.
No one is asking a last one. So you said you did not want to augment use the T service mapping model. Again, is it because of the technology agnostic approach that you're taking, or?
No. So basically, if you see in the T service, we have a common model, which is just a grouping. And then what we do is we have augment of L3SM, augment of L2SM, augment of L1CSM, all these multiple models in the same draft. We could also add augment of IETF network slice. Right now, we want to keep it in a separate document because when last time I was presenting this T service, this was the exact question I asked the working group. And at that time, the idea would be that we will be blocking T service mapping for a long time. Let's get this separation. That's one reason. And second, none of the other things care about NRP. This would be the only one where NRP concept is coming in. So it makes more sense to keep this separate and add the NRP concept only for IETF network slice mapping and keep the other things separate.
Okay. Well, let's discuss that more on the list.
Sure.
One, you currently augment the slice service model.
Yes.
So why don't you consider moving this to the service model itself?
I think we could do that, but that working group also thinking of it as a working group. Last call, again, you add things, that whole thing changes. But it is pretty straightforward.
Self-contained, small enough.
Yeah, if the working group feels this is useful, yeah, it can be done. Only thing would be then the moment you do that, then the NRP Yang model also needs to be standardized before this happens. So moment you try to put this in the NBI, that's also something to worry about. I would rather not do that. I think it makes more sense to keep it separate.
So while we're bringing you up for the next one, I got a, oh, I thought, what's that?
Drew,
Oh, sorry, Sergio, I missed that. Go ahead.
yeah, you hear me? Okay. Drew, just a clarification. It seems to me that you augment a prefix of the module as a network slice. But if it is a MBI young model, it seems to me that is NSS uh, prefix. So, am I wrong?
Are you talking about what is the prefix that I use in the Yang model?
Yes, yes. The prefix, if you use the augmentation from NBI model, it is IETF N double S, NSS. But I noticed that in your augmentation is just NS.
Okay. Oh, sorry. So I'll fix that. Thank you for pointing
okay.
it out.
So, okay.
Yeah, my mistake.
All right, we're going to move on to the next one. I actually received a private message to ask the room to please put on masks if you are sitting in the room. Thank you.
So let's move to the second one. Again, it's 03, but first time I'm presenting this. This is about traffic mapping Yang model. Next slide, please. Again, when we were discussing T-service mapping, this was one of the open issues that were listed, that we don't really have a good way to also tell what traffic flows in the paths and the services that we are currently establishing. So this is an attempt, again, sort of like a straw man, getting a feel from the room that whether this will be useful work to continue or not. Yes. So background, we know that in IETF, we have various Yang models. We set up various T services, tunnels, paths, SR policies, all that stuff. But we don't really have a good Yang model that clearly says what traffic flows over these paths and services. We have various different things, like we have ACL. And then what happens is at various models, they try to do it themselves. IETF network slice is also trying to do it via something called as a match criteria. We have protocols like BGP and PSEP, both have flow spec as a way to signal this. And some of the models also have the flow match criteria based on IP, UDP, and TCP headers. So we have various people doing various different things, but not something that is standardized in the Yang model point of view. So the question is this even possible? Are we too late? And if we want to do it, what is the right way to do it? So these are the questions in front of the room. So let me just give at a very, very high level what my thinking is, and then we'll open the discussion. Next slide, please. So where could this be useful? I think there are various ways where having a standard traffic mapping model would be quite useful. Various Yang models do not mention this at all, and people use their own proprietary way to figure things out. Outside of just TE, there are various different things happening in IETF. For instance, traffic classification for service function chaining. AP and BOF was supposed to happen, didn't, but they also have traffic classification. So this idea of having a way to identify traffic is quite important at various levels in the IETF, but we do not have a standard way to do this as of now. Next slide. Now, the issue with this kind of mapping would be that should we pick one? I don't think so. That would make sense because people have different requirements. They map it using different things. They will use different way to achieve this. So should we have this as a way of just maintaining the various different ways in which you can map? You can still create an ACL, but just maintain a reference so that I could try to figure out what traffic is flowing where, what is the actions being taken, maybe doing some statistics as well on this various different flows. So continue to allow multiple ways to do this, but still maintain in a common place what kind of mapping is being done. That's one approach that we were discussing. It is not ideal, but it's one approach. We don't even have, for instance, a flow spec Yang model as of now. So this is just things in the air. But some of them we have. ACL model is pretty good. saying things that whatever traffic that you receive on a particular interface, the things that we do for VPN, pretty straightforward. We can directly have a way to identify the sites and interfaces and port numbers. That's pretty straightforward. So some parts are straightforward, some part not, but this is at a high level what could look like a good traffic mapping YANG model. Next slide. Just a rough tree of various things, having some statistics, having some actions, that could also be useful. Again, keeping it optional so that you could do it in various different ways. That's what is proposed here. Next slide. But the main question is this even useful? Basically, the models have been developed. People have been doing their own ways. This is not a new problem. People set up a service because they wanted some traffic to flow. They have solved this problem in different ways. Maybe we are too late and there's no point of continuing this. Then maybe this will be the last time I'll present this. Or if there is an interest that this is useful and the approach that we are taking is correct, then we may continue to do this work. And again, does this work belongs in this group or should we go somewhere else? That's something that we need to also figure out. Thank you. Let's keep more time for questions.
Charles? Go to the next one. You on the next slide? Next slide. Oh, just this thing.
Yeah, Charles Eckel, Cisco. Thanks for the presentation. I think it was really good. I also spent some time in MEF and working on SD-WAN stuff over there, and we had a similar need for this. We didn't see any kind of general purpose like way of not just classifying, but indicating what the classification was. So we did like many people do, defined our own. It is a bit special purpose in that it's meant for SD-WAN applications where classifying application traffic as it comes in is very important. So what we did is we have a number of things, some of which you mentioned here, based on IP address, port, source, destination of those. And then we have kind of a wild card of just you assign an application ID because so many people were using DPI, some type of special sauce to identify traffic. And the key thing was once it's identified, then the customer of the SD-WAN wants to be able to say, well, this is how I want you to treat it, or these are the important aspects for it. So anyways, we have that. We'd be happy to help people, see that, see if it matches your purpose or fits into this general category of what you're looking to do, and kind of go from there.
Thank you. Please send me the link.
Yeah, sure.
I'll actually ask both of you if either of you were in NetMod this morning.
No. Flash.
Yes, I was in that.
Okay, so if you heard in NetMod, there is a discussion talking about revising the ACL base model. And it seems like there's some synergy here. And either you could do your work by further revision of ACL or an augmentation of that new work, at least the classification part. And that might also apply to Charles, what you're talking about. So you might want to look at that document and see whether or not there's good synergy.
Sure.
If I've misread and you're really talking about more about routing policy, I'll remind you everyone that there's a routing policy, but I didn't think, yeah, okay. So moving to the next is Pavan.
I'll give a quick update on the data model draft that discusses topology filters and topology filter sets. This was initially presented in IETF112. There were some comments and questions raised. We discussed those on the list, and an update was published addressing those.
Just hold it.
How about now? How about now? This was introduced in IETF112. There were some questions and comments raised. We discussed those on the list. There was an update published addressing those comments, and I'll cover those changes in the next couple of slides. I'm Pawan Biram, and I'm presenting this on behalf of my co-authors Tarek, Rakesh, and Shrifan. Next slide. The topology filter construct was originally modeled as part of the network resource partition policy data model. Given its generic applicability, we published it as a standalone module. There were some questions about the scope of this construct. So we did add some text in the introduction clarifying that. It's a construct that's used to filter network topologies. It can be applied on either a native TA-aware topology or a native or a customized TA-aware topology, as discussed in RSC 8795. Application of this on a topology would produce a filtered set of topological elements. Topology filter set, on the other hand, is just a union of multiple topology filters that can be applied in tandem on a topology. We also went ahead and added a note to explicitly state that this is used for filtering network topologies and not for filtering entries in the REB. Next slide. Next slide. There were also some comments about potential use cases for this. So we went ahead and added a section describing a couple of use cases. One is the specification of topology associated with network resource partition. The other is specification of topology-related constraints for TE path computation. We did add a few examples for each of these use cases. Those are listed in the document and reproduced here on this slide. The rest of the deck goes over the model structure. There hasn't been any changes to it since the time we presented last time. So I'll not repeat that. Can we jump to the last slide? Or the next step slide, the one before this. At this point, we are just requesting further review and feedback. This is a prerequisite for the NRP policy data model. At the point where we would claim that the NRP policy data model or the merged document that Bo was alluding to earlier is ready for adoption, we will put in a request for this to be considered for adoption as well.
So I'm going to ask the same, in one moment. So I'm going to ask basically the same question I asked at the last one. There were some comments that it was a little confusing. So this is gauging interest. It's not about adoption. And, raise hands if you're interested in hearing more. No if you're not, or you think the draft is going in the wrong direction. And no response means don't care. Sorry about the 3-state, but that's our poll tool. And G, if you want to ask your question.
Yeah, Xidong from Huawei. Actually, my question is, I think this topology filter is mainly applicable to perform the TE or centralized path computation. So you can use these filters as constraints for the controller or the ingress node to compute the path. But whether it can apply to the distributed path computation like you use, can it apply to the multi-topology or can it apply to the flash algo? It is not that clear to me at current moment. So I think it can be clarified further in the document.
It can be. We can add an appendix with examples for that.
All right, we'll give just a few more moments. And the next speaker is going to be Greg. So we've had about a third of the room respond. It looks like slightly more are interested than not, but we definitely got some good not interested. So it's the room is mixed, but I'd say the working group isn't convinced about this work, but still should hear more. Thank you. You want to switch? I'll switch. Sorry.
Thank you for granting the time to update you on the work that being done in IPPN working group on precision availability metrics in multi-SLO governed end-to-end services. Next slide. So we had two groups of authors interested in this problem, and then we worked together to merge this into one document. And we had first working group adoption poll in IPPM working group, and in the meeting earlier this week, we agreed that the version of the document that reflects comments that we received will be uploaded, and the second working group adoption poll or continuation of the working group adoption poll will be announced. Why we are presenting to TEAS? Because we believe that this is important for traffic engineering and network slicing operations, and the TEAS working group has an expertise on those topics. So we hope that it will get your interest, and you will review this document and share your comments, including on IPPM working group list. Thank you. Next slide. So what is the problem? Since SLOs compose of service level agreement, they're the key, and they need to be considered. In many cases, just one violation does not mean a lot. So instead of keeping the history of all the measurements of all the raw data that are being collected for the given service, that can be aggregated and concentrating on when the service is crossing the threshold. So basically going out of the defined parameters acceptable for this given performance metric. So capturing these violations or asserting the absence of asserting conformance to the SLO is sufficient to draw the conclusion of and assess the quality and conformance to the required SLO. So there is analogy between the service and system failures, and the failure is to be considered when fail to deliver to the required performance metric. Next slide, please. So what is precision availability metric? So it expresses availability of the service in accordance with the performance required reflected as it expressed as a service level objective. And I would like to stress, because as mentioned, that we believe that this is very much applicable to work being done in TEAS on IETF transport network slices. We follow the terminology defined in network slices TEAS document. And that both for SLO as service level expectation and service level agreement. So the service level agreement, because as defined and agreed upon that they are well, there are some parts of SLA, but they are difficult to measure. So these are outside the scope of this work. So the performance requirements for various network services can be expressed through the combination of SLOs. So thus, the conformance of the service is the combination of each individual SLO that is a part of SLA. Next slide, please.
Sorry.
No, that's fine. So here we come to the composing service. And as discussed in IETF network slice document, composite service might include connectivity constructs. So all constructs may be assigned for the same set of SLOs. or some construct might be assigned a different sets of SLOs. So in that case, each connectivity construct that composes the service can be monitored according to its own set of SLOs. Then their PAM for their composite service will be a supposition of PAMs of these subservices. So if you have any questions, so feel free to sign, well, indicate, and I think the chairs will bring it to my attention so we can have a discussion. I think that it will be better if I will go all end and then we have to rewind to the beginning of the presentation. But let me continue. Next slide, please. So applicability, where we think we believe that PAM can be used. It can be useful in determining degree of compliance, which service levels are delivered relative to predefined SLOs. And here what we envision that interest from operator perspective and from subscriber perspective could be different. For example, what we define the violation of SLO and severe violation. So where their violation is probably more of interest to an operator, and it indicates the degradation or sufficient degradation of the particular performance metric crossing some threshold. But severe violation is the violation that crosses the critical threshold, and that both may be of interest to operator and subscriber. But again, nothing prevents it having only one threshold, which is a critical threshold. So also PAM could be useful in providing service according to SLO as accounting records and assess the quality with which service is delivered and monitor it continuously. Next slide, please. Again, one of the foundation elements of PAM is the time unit, PAM-TAM unit. So it is the unit on which their particular performance metric is being measured, and then their conformance to SLO being evaluated and expressed, either it's a violated interval, violation-free interval, or severe violation interval. An example of time interval could be 1 second, 1 millisecond, or to the liking of the user. The only is that requirement, and I think it's logical, that time interval for all SLOs that are included in a given SLA should be the same. Based on this definition, we define their set of basic metrics, which is the number of violation intervals, violation-free intervals, and severe violation intervals. But the number itself probably does not reflect the state of the particular SLO and service. So next slide, please. So from that, we can have some derived PAM metrics that might be useful. Time since last violation interval, mean time, number of packets, mean number of packets, and that are applicable to both violation intervals and severe violation intervals. Next slide, please. And an extension. So here's probably might be the interesting part. The availability or unavailability of the service can be expressed based on the state. And because the state has to be sticky, so not to switch, what we define is that availability or unavailability states expressed as a lengthy, uninterrupted, continuous state, whether it's a severe violation state or violation or violation-free intervals, consecutive. So for example, it could be that 10 consecutive severe violation intervals constitute the unavailability state that began at the beginning of the first interval. Similarly, 10 consecutive non-severe violation intervals, which is violation intervals or violation-free intervals, will constitute a transition to availability state beginning from the first non-SVI interval.
You need to wrap up.
Yeah, next slide. We're getting there.
I think you need to be last slide.
Yeah, so we have some discussion items and some future work out indicated. It's in the document. We welcome cooperation. Next slide. Oh, okay, as mentioned, please read the document, share your comments on IPPM working list.
I'm sorry, we don't have time for it. Also, this is informational. Please take your comments to the IPPM working group. Thank you.
No, TS and working.
Sorry.
IPPM.
Gabrielle?
Yes, thank you. Can you hear me?
Yes, you sound great.
Okay, thank you. Okay, next slide, please. So this just an overview on the motivation of this draft. As we know, the networks are layering, and then there is the need to manage the full network independent of the layers. And then I think a great job has been done by ACTM POI applicability. But recently, we see the new pluggable interfaces, DWDM interfaces coming on the market and moving, for example, what is the transponder-like functions from the optical layer to the IP layer, so that this open a number of use cases, because actually a part of the optical components are in a different layer than the optical layer. And so in theory, the pluggable should be managed by the packet controller instead of optical controller. On the other side, the optical controller needs to know what kind of transceiver or what kind of pluggable has been fitted in the router, and then this is used to make the optical impairment verification and all that stuff. Next, please. Okay, in other words, this is the network topology we are addressing. No, so we have the packet network element with P1, P2, P3, which are the pluggable, DWDM pluggable. We have the optical network, and then so we have sort of mix and match. Next, please. To address this kind of network, as you can see, we are adopting. We are not making anything new. ACTN solution is the good one, where we have an hierarchical controller, which is MDSC, and connected to the hierarchical controller, we have the packet PNC and the optical PNC. Of course, in some way, the packet PNC and the optical PNC needs to share some information related to the pluggable. Next one. Thank you. So the service can be either DCO link, so it's a pure optical circuit, if you want. That is, by the way, terminated on the routers. There are some interlayer link to be defined between the router port and the road ports. And then on top of that, we have Ethernet services, IP services, and whatever. And of course, is a matter of MDSC to manage all this stuff, helping the packet and the optical PNC. Next one. So basically, in the draft, we have been identify a bunch of use cases that I don't want to go one by one, but basically the matter is to identify the interlink connections first, and then each controller, so domain controller, can share with the MDSC the network topology, the layer topology, and the MDSC will rebuild the full network topology. At that point, MDSC can manage and can drive end-to-end services, or that can be done at IP level, or can be done at optical layer, or also drive restorations and so on. These are actually described in details in the draft, so I would like you to have a look to the draft and then feedbacks. Next one. So next step is actually to address the use case, but also to add new one, like for example, end-to-end performance management, alarm correlation, and not only this one, because I feel there are many other use cases to cover and to address in order to, let's say, help the operator, the network operators to support this kind of network topology. Of course, we want to keep aligned this draft with the ACTM POI applicability, and then get feedbacks and consensus from the team. So especially the feedbacks, because this is quite important point. The technology is running fast. The deployment of the pluggable in the field is running very fast, more than expected, probably. And then, so we need to address this point. Last but not least, we would like also to help the YAM models definition. We don't think for the moment that the YAM model will be defined in this draft, but we should identify the good one already existing in other draft and maybe ask to the other draft to add new models. Okay, that's all. Thank you.
Gabriele,
Thank you for your
Gabriele,
time.
did you, we are over time, but I'll just sneak in a quick question. Did you consider discussing this as part of the working group adopted document? Just
Let's say, we as you know, we have a design team on ACTM POI. I would ask the design team also to discuss about this draft. And then, I don't know, this is 00, it's a brand new draft, so I wouldn't expect to have now.
Bring it up in your bi-weekly meetings and then report back to the list.
Yes, yes, thank you. Thank you.
Thank you.
Thank you to you.
We will wrap up the session here. Thanks everyone for a very productive session here. We will see you all in Yokohama. Thank you.
Okay. Bye-bye.
Bye. Thank you.